Hi, this is Charlie Rich from jKool. I'm going to present a brief demo of jKool, our software as a service solution for real-time operational intelligence. And it can visualize and analyze streaming data from Java applications, including logs, metrics, and even track transactions. We're going to take a look at a scenario for order management and our visualization layer during this session here. You're looking at the jKool dashboard, highly configurable and customizable. It's broken up into multiple viewlets. These viewlets are driven by questions. These can be a simple expression where we're looking for events or applications or activities and pulling this out of our NoSQL repository, or it could be a real-time subscription where as events come in out of memory, they immediately appear on the screen according to the query. The query language is an English language query tool that we call jKool query language. So let's jump right in. We're looking at a pie chart, and this pie chart is built based on the expression of get number of events, where the event name contains order, group by event name, severity, and show as a pie chart. So real simply here, we have all of the different orders, and we have their severity as well. And this is an aggregate, if you will, where we've added up. There were 72 read order events with a severity of failure. I can drill right into this here, and this will pull me into my console where I get the detailed information about each of the read order events, where they were located, how long they took, what their relationships were, any messages. I can drill still further, and perhaps I'll pick the first 4 of these and I'll do a deeper analysis. Now this is going to run a stock panel chart where it'll show a comparison of the events in candlesticks, whether they've changed over time. And candlesticks here are used in red to show that the close of this period is lower than the open. And here's the opposite, where the close is higher. We're looking simultaneously at the elapsed time for these events, along with memory utilization and CPU availability. And at the same time here, make this a little higher here, we're looking at everything else that's going on and the volume. So you've got a snapshot view of how long my events took, how much system resources I'm using, and what else is going on. And these are represented here as candlesticks, and down here we've got a column chart. Now, alternatively, I could have analyzed several of these, and instead of showing that sort of graph, I might want to compare these. And automatically on the fly, I generate a comparison where I'm comparing the different read order events, and for any numeric fields, I'm calculating automatically the difference. And if I wish to change which is the master and which is the one I'm comparing, I can simply click here. And one more choice on that, I might want to have picked on the orders here, let's pick topology. And this is going to show where these events happened. So here we have some different applications, order router, process payment, ship payment. And here I can see the flow that we've automatically detected during our discovery, and then even the status. And on the health bar here for process payment, we have a variety of statuses based on the different events that have occurred over time. And if I wished, I could drill even further and go into the errors, the failures, the critical, etc. So this is a way of very quickly, with just a couple of clicks, diagnosing what's wrong. Let's take a look at a few other elements on the dashboard here. Another interesting one you see here are Bollinger Bands. This is a way of automatically detecting anomalies. So here we're getting fraud events, and we're bucketing them by hours. So we're getting them as they come, but we're showing them in buckets of hours and showing this as an anomaly chart. In our anomaly chart, using Bollinger Bands, we smooth out the actual values using exponential moving averages. Then we calculate an upper and a lower band, 2 standard deviations above and below. And whenever we transcend one of those bands, we automatically have detected an anomaly. It's a very powerful tool that lets you get away with not having to set a high watermark or a low watermark and still being able to detect anomalies and find a pattern in the data that you didn't know existed. All of these viewlets are all configurable by changing the jKool query language we're looking at here, or you can also edit these by going into the menu. And here we could change our standard deviation, we could change the time period, and each of the charts has a variety. I could change to another type of chart, etc. Very powerful in that regard. Moving down, we'll take a look at another example here. You can see we do geographical topology discovery, and here we do dependency. We're tracking transactions. So I'm getting the relatives from order management. You can think of this as a group or a business service, whatever is most appropriate. And here I've detected the flow. Automatically, I'm looking at the messages that are sent between these, and from this I can derive the flow, and I can drill into the details from that as well. Here we're showing this in terms of applications. We could also show this in terms of servers or geographic as well, and get another view of that same data. Now, to learn how to use this, there's a tutorial, which is a very nice walkthrough that will show you how to use some basic jKool query language queries, build your own viewlets. And to get started yourself and stream data, you can click on the Get Collectors, and we have a variety of open source collectors for Log4j, SL4 4j, Logback. We have ones for Spark, for JMX, for HTTP, and we're always adding new ones as well. I hope you found this helpful, and I certainly welcome you to jump in, sign up. It's free. There's a free offering that's perpetual, and you can play with the sample data. You can download some collectors, use the tutorial, and start getting really comfortable with jKool. Thank you very much.